So our last topic of discussion on the idea of winds and air pressure is an idea called small scale winds. And here's what you need to do. Periodically throughout this presentation, you're going to see a slide after I introduce a concept, and it's going to be a set of check for understanding questions, and you must copy those questions into your notebook. Yes, I said you have to copy the questions because the answers don't do you any good without knowing what you're answering. In order to get the done stamp, I got to see those questions and the answers. In addition, there are some diagrams. It's a very visual lecture here that I need you to draw out the diagram so you get the understanding. You will not get the done stamp unless you have the sketches and the diagrams drawn as you are instructed throughout the video. Now, let's talk about some review of key ideas. You do not have to copy these in your notebook because we already have this information, but this is just to kind of jog our memory and get us thinking about this presentation. What causes wind? We know it's a difference in pressure. Well, what causes a difference in pressure is a difference in temperature. Well, what causes differences in temperatures? This we spent a whole unit on, and we know there's a lot of things. Changes in elevation, the water here or there, one air mass coming in and replacing another, where the jet stream is, you have different colors, more or less plants, you have lots of things that change the temperatures. So at this point, we understand what wind is. Wind is the movement of air from higher to lower pressure. And we also understand that high and low pressures are caused generally by differences in temperatures. We understand there are parts of our country that are hotter or colder than others, and that sets up generally high pressures in one location and lower pressures in another. But you can also have what's called a small scale wind. A small scale wind is a wind in a very small area where you have a slight difference in pressure caused by a slight difference in temperature. Consider this area here. We've got a nice dark black parking lot underneath a nice sunny sky. The parking lot's getting hot, and we know that the air over the parking lot, if it gets hot, it's going to rise and generally create a low pressure. However, over here we've got some nice green grass, and we know the grass is not going to get nearly as hot, so the temperatures in this area are going to be slightly lower than over the parking lot. Well, that's going to make air not rise. It's going to make it sink or create a little bit higher pressure here than you had over the parking lot. Well, now we got two areas side by side that have slightly different pressure. So we got a little bit higher pressure here. That is then going to push to the area of low pressure. That's what a wind is. It's the movement of the air from this area of a little bit higher pressure to an area of a little bit lower pressure. But this is in a small area. Hence, this is called a small scale wind. Now that difference in a small area of pressures because of differences in temperatures in a very small area can lead to this first small scale wind we're going to discuss, and that's a land and a sea breeze. So let's talk about our first example, what we call a small scale wind, or a wind that's usually found in one particular location. And you'll see here I'm at the beach. And if you've ever been to the beach, you know there's typically a breeze at the shore, as you can see from this flag behind me. Well, let's talk about why. Remember that wind is the movement of air from high pressure to low pressure. So where's the high and the low pressure here? Well, first of all, think about the temperature of the ocean. The temperature of the ocean doesn't change very much. Even though it's a nice, hot, sunny day, that water is going to stay relatively cool even out in the hot sun. Well, if we look back there behind me, we've got a bunch of buildings, we've got a bunch of land, and all that's going to heat up a lot more quickly, which makes the air hot and makes it rise, making a lower pressure. So out here, where it's still a little bit cooler, the air is going to be sinking and making a high pressure. And air moves from high pressure to low pressure. So at the beach, you tend to get this onshore movement of wind during the day. That's called a sea breeze. And the sea breeze is formed when you have the cooler water making a little high pressure and the warmer land making a low pressure. So let's diagram a sea breeze for our notes and explain what's going on that gives us this movement of air that we call a sea breeze. Well, first of all, I'm going to draw myself a nice happy little sun here because we know it's going to take some change of temperature to make a change in pressure to cause any kind of movement of air. Well, sea breeze means we need the sea. So I'm going to draw myself my little ocean right here, and then I'm going to draw myself my little beach.
That's my beach, and there's my ocean. Now let's talk about what goes on to give us that formation of a sea breeze. Okay, first of all, we know that the air over here is going to get hot and rise because the beach or the land gets hot easier than the water. So we're going to say land gets hot, and we know hot air rises, which makes low pressure. That's exactly what happens. But the air can't go up for an infinite distance because gravity still works. So it wants to get up here and it wants to spread out. It wants to move apart. And it has a hard time moving inland because there's more land over there and more air still trying to go up over here. So what happens is our air does this. The air expands and moves out over the water. Because that's the way you can expand. And we know that hot things want to expand. Now, once it gets out over the water, and remember the water's a little cooler, so the air here over the water isn't rising, it's actually sinking. So air over the water is sinking. Now, air sinking means there's going to be more air down here, which forms high pressure. Well, now we've got an area of high pressure here and an area of low pressure here. High pressure here, low pressure here. And when we have unequal pressures, nature is going to cause things to try to equal out, and we're going to get the movement of the air from the high pressure to the low pressure. So we get wind moves from the water to the land. The water is the sea, hence we have what's called a sea breeze. Because if you were standing right here, you would feel the air coming to you from over the water or from the sea, hence the name sea breeze. This is what you need to understand, and this is the diagram that you need to have in your notes.
So let's look at the land sea breezes in this particular situation here. Notice I'm at the beach, I'm at the shore, but there's almost no breeze because you can see because there's no waves here. And that's because it's first thing in the morning. So it's been night, which means that this ground isn't very hot because it's been dark. And when the ground isn't hot, the air over the ground is not rising, which makes the air coming from the water this way and then go up and make a sea breeze. So sea breezes are weakest first thing in the morning when the ground is not hot. So here I am in the same location at about 3 o'clock in the afternoon, and you can tell by the sleeve of my shirt and the water back there behind me that we've got a lot more wind now. What's changed is that now at 3 o'clock in the afternoon, this land out here has gotten hot, sitting under the sun. Well, the hot land has air that is rising over it, creating a little bit low pressure. Well, the air over the water is still cool, so it has a little bit higher pressure. So remember that air moves from higher pressure towards low pressure. So now we've got that formation of a sea breeze. And a sea breeze is always going to be strongest when this land is the hottest. So typically late in the afternoon, like it is now, 3 or 4 o'clock.
You can actually see it in the hourly weather forecast. If you'll notice here, and I draw on this,
Notice here at 5 a.m. where the winds are 8 miles an hour. But as the sun comes up and the temperature really starts to increase, we see the winds start to increase. They keep getting higher and higher as the day gets hotter and hotter, and the temperature difference between the land and the ocean is more dramatic. Well, then as we go further through the night, you notice the temperature goes down, and what you'll see is that the winds start to go back down again.
Now let's talk about what causes the phenomenon known as a land breeze. Land breeze, now notice it's nighttime. We've got the moon and the stars. It's nighttime. Well, at night, the beach cools down a lot more than the water because we know the land changes temperatures a lot more easily than the water. That means this is actually cooler than this right here. Well, over the cooler part, the air is actually going to be sinking. And you're going to get a creation of a high pressure right there because it is cooler here now than it is right here. Well, the water's still kind of warm, which means the water is going to evaporate a little bit more now, and it's actually going to be rising. Well, the rising air is going to cause us a little bit of area of lower pressure. And we know that wind always moves from high pressure to low pressure. So the air is going to move like this. Now, this air, when it rises, it's going to want to move this way because that's the way it can expand once it rises, gets over the land, which is a little bit cooler, and it's going to sink and fall. And now we have what's called a land breeze. If you were standing here on the shore, you would feel the air moving from the land out to the water, hence the name of a land breeze.
So here's our first check for understanding. You got to come up with questions. What causes sea breezes and land breezes along the coast? And you got to sketch those diagrams. Hopefully you drew them as I went through the lecture. And then the idea of when are they strongest and weakest, and be able to explain why. Now there's other local small scale winds as well, not just land and sea breezes, because there can be a big temperature difference between very small areas. Think about these two areas. Think about the temperatures of these two areas on a nice, hot, sunny day. Well, we know the city is going to get really hot and the air is going to rise very easily. Well, we know over here it's going to be cooler because the water and the air is a lot more likely to be sinking. If these two areas are right beside one another, you're going to have some wind because you're going to have a local low pressure right next to a local high pressure. That is generally what we call a thermal. A thermal is a small pocket of rising hot air. And this happens a lot in cities where the city is significantly hotter because of that urban heat island effect than the countryside around it. Think about this area here. We got a little kind of a marshy, swampy area in the middle of the city, surrounded by a lot of buildings that are going to get hot. So you're going to have hot air rising and then cold air sinking. You're going to have two columns of air side by side that are doing different things. Same concept here, a freshly plowed field. Nice dark black soil is going to heat up, but the green grass around the field is going to stay cooler. Thermals is the reason why things like hang gliders work, or why you can see birds up in the sky and they're not moving. They look like they're just kind of hanging up there in the air without flapping their wings, because they have found that pocket of air that is rising and that provides lift because the air is moving up. It's also the reason why we have turbulence. When you're flying in the airplane and you get that kind of bumpy ride, what you're actually hitting is those little pockets, of rising hot air. So your plane's going along this way and it encounters some air that is going up. Well, that pushes the plane up. Well, once you get past that little column of rising hot air and you lose that push up, well, the plane moves back down. So that's why you have a bumpy ride. It's caused by uneven temperatures over the ground, which makes air rise and fall differently. It's also one of the reasons why most of the time, if they can avoid it, planes don't fly over the downtowns of large cities. This is pretty significant. You'll notice this here in Atlanta if you've ever flown in and out. The planes very rarely ever fly directly over downtown because that area where it's all buildings in downtown Atlanta is going to be a little bit hotter generally, and you're going to have rising thermals there, which is going to make a bumpier ride as you're coming in for a landing. Now, this idea of a thermal also lends to or also causes a phenomenon we know as a dust devil.
So we're going to take a look at a special particular kind of thermal called a dust devil. Remember that a thermal is a small patch or a small column of rising hot air. Well, where does the heat come from? It always comes from the sun. So we're going to have thermals and we're going to have dust devils on nice, hot, sunny days. But there are places where thermals happen more so than others. There are places where thermals don't tend to happen, and that's where the ground is cool. So I choose my ground, and it's covered with grass. And we know that grass as a plant doesn't get very hot very easily. So anywhere I'm going to have grass, it's going to be tough to have a thermal because the ground and hence the air over the ground is just not going to get that hot because plants help keep things cooler. But imagine that I had a little exposed path of dirt. It's got some loose dirt right here. Well, if the sunlight hits that dirt's going to get hot. And the air over the dirt is going to get hot. And we know that hot air does what? It rises. So we're going to have something like this going on. The air right there is going to be rising, whereas the air over here will not be rising. But if this air is going away and it's making a little bit of lower pressure, that means the air over the grass is actually a little bit of higher pressure. And we know that air is going to move from high pressure towards low pressure. So the cooler air is going to run in there to take the place of that air that has left. Well, that means we're going to have air moving that way and then going up. So this is a good example of a thermal. It's a little area of rising hot air, and it could happen over dirt, it could happen over a parking lot, over a building. But when it happens over dirt, especially loose dirt, something unique can happen. The dirt can be picked up with it. So you can actually see the thermal. Most of the time they're invisible, it's just air. But if the dirt is going up with the air, we'll see like a dirty wind. It looks dusty, and these are actually called dust devils. They look like little mini dirty, dusty tornadoes. Now, these things actually spin because just like water going into a bathtub, going down the drain, doesn't go straight in, it spins, partly because due to the spinning of the earth. So as this air rises, it does that. And that little twisty shape of the air makes it look kind of what we think about with tornadoes. But it's not a tornado because tornadoes come from thunderstorms and they come from a cloud and go to the ground. This is going from the ground up. This is called a dust devil. Well, what is a dust devil? It is a thermal updraft that picks up dirt. Which means we can see it because it's like a little, what we usually call a dirty tornado. But they're not tornadoes. It's just a moniker that is kind of stuck because they have that same swirly kind of shape. Now, some questions about these dust devils. Where would these happen? Well, they can only happen where we have a small patch of dirt that the hot air can pick up as it rises, typically next to some place that is a little bit cooler. So, for example, you get these on baseball fields a lot. Because think about a baseball field. You have a grassy outfield, maybe you have a grass infield, and you got a little dirty part like on the infield. And that part gets extra hot, and that's where the thermal will form and pick up some of that dirt. You have thermals that happen over parking lots, but they don't turn into dust devils because there's no dirt for it to pick up. You can't see it. Is the air rising over a hot parking lot? Yes, but because it doesn't have any dirt to pick up, it doesn't turn into a dust devil that we can see. When are these things going to happen? Typically, late afternoon in the summertime, because that's when the ground has gotten hot enough. You don't see dust devils in the morning because the ground hasn't gotten hot enough to make that thermal updraft yet. You typically don't see them at night because once the sun goes down, we cut off the energy for that air to rise. Where? Dusty or dirty places. We don't tend to see dust devils here in Georgia. And the reason is we have too many plants and trees. Most of our ground is covered with plants and trees, so it's hard for us to get these little dirty rising columns of air. Where would you see these things? Well, you see them a lot in the west, because in the western part of the country, we have a lot more exposed dirt. We have a lot of deserts. Nevada, Arizona, Utah, places like that. You'll see in West Texas. There have been times where I've been in West Texas driving and I'm looking around and I can count about 20 dust devils at one time. So once again, a dust devil is a thermal updraft that picks up dirt and we can see it.
Here's what a dust devil looks like, and it looks like just what I said. It looks like a dirty tornado. However, tornadoes are attached to clouds, and you'll notice that these dust devils, they just kind of go up in the air and then they kind of disappear. The reason why they get up there and they disappear up here is because up there it's cooler, so the air doesn't rise as much and it mixes with the colder air up there and it just kind of dissipates. Here's a short video that kind of shows you what it looks like. Notice it's across the dusty or dirty part of a baseball field. It looks like it's a nice hot day. It's a clear sky. Air got rising over the ball field, and you can see it picks up some dirt and it makes a little dust devil. Now, here's one that's a little bit more substantial. Now, how much damage did these things cause? They're not like tornadoes, but you see it caught a tent. There's a little roadside fruit stand. You can see anything that's lightweight, it picked up and started throwing around. They're not nearly as damaging as tornadoes, but they can be powerful enough that they can do a little bit of damage. So here's our check for understandings at this point. This is what you should have copied into your notebook and be able to answer based on what you learned from the past section of the lecture. Now we're going to move into a downburst or a microburst. You recognize this cloud here. You know this is a stormy, rainy cloud, and you can actually see the rain is falling from the cloud. Well, when rain falls from a cloud, especially from when it's way up there in the sky, all of the air that's down here gets pushed towards the ground because the water, as it's falling out of the cloud, pushes the air ahead of it. Well, when the air then hits the ground, it can't go into the ground. Like the water will hit the ground and sit on the ground and then soak into the ground. But the air can't do that. And what happens with the air when it hits the ground, it gets pushed sideways. It'll do something like this, especially as more air is coming down behind it. Well, that movement of air is what wind is. And this is more specifically called a downburst or a microburst. You'll see both terms interchangeably. Downburst is nice because it kind of gives you the sense of what's causing it. It's air coming down from a thunderstorm, pushing the air out ahead of it. And it has a very unique shape to the wind. It doesn't go very far, it doesn't extend very far beyond the edge of the cloud, but as the air comes down and it gets here, well, now over here where there is no rain falling, you don't have that higher pressure, that increased squeezing and pushing of the air. So when the air gets out here, there's a little bit higher pressure. Remember, the air is going to move from high pressure to low pressure. So it'll move up to here where the pressure is a little lower because there's not any rain falling. So it has a diagram like this. Rain falls and pushes the air out ahead of it. When the air hits the ground, it has to go sideways. When it gets out from underneath the cloud, it'll curl up in this direction to make a very uniquely shaped, kind of curled upward wind pattern. Now, most of these downbursts are not damaging enough like a tornado or a hurricane. However, if you have a lightweight structure that isn't very strong, like in May of 2009, the Dallas Cowboys had a tent, basically a metal frame tent. It's a permanent structure, but it's not really a building. And a downburst came down strong enough during a thunderstorm that it actually pushed the roof of the facility all the way to the ground, and 12 people actually had to go to the hospital. For the most part, a downburst isn't going to damage your house because if you think about your house, think about what the shape of your roof is. As downburst comes down, it's going to be deflected off of your roof like that. But where downbursts and microbursts are very, very serious business are with flying. I want you to think about air coming down and the pilot trying to land his plane. Pilot lines up his plane for the end of the runway. He knows what the winds are. He kind of knows what the speeds are. He's got his plane lined up. Well, let's consider this microburst that does this. The pilot's got his plane lined up and he gets to this point right here. And what does he feel? He feels a little bit of air or a wind pushing the plane a little bit upward. And as a pilot, he'd be like, oh, now I'm higher than I need to be. I need to push my plane down. I need to adjust my trajectory. So the pilot pushes his plane a little bit downward to compensate for that upward air. But then a few seconds later, the plane's right here. And now we've got air pushing down on the plane, and the plane is already aimed down. What you get is a crash of the plane short of the runway. These downbursts, microbursts make flying in thunderstorms exceptionally dangerous. So one of the reasons why, if you've ever been to the airport and they stop the flights, they hold the planes, or they won't let you land, it's because of these downbursts and microbursts. You're not ever really 100% sure when they're happening and how strong they are. So they don't take chances flying planes usually in thunderstorms. That leads us to a concept of what's known as wind shear. Wind shear is a very general description about wind. Wind shear is any sudden change in speed or direction of the wind. And this is very important for flying. You need to know which way the wind is blowing when you're flying a plane. Is it pushing me up or is it pushing me down? And if it changes in an instant, especially while you're close to the ground, it can cause the plane to crash. And there are instances where planes crashed and people were killed because of this idea of a downburst or a microburst causing a wind shear, a sudden change in the wind speed that the pilots weren't ready for. This was fairly recently. This was a FedEx plane in Memphis. So now what do? around airports, they have multiple anemometers. And in this day and time where we have a lot more computing power and we have information in real time, they'll have anemometers all around the airport, and it can measure the wind speed and direction so that we can get that information to pilots very quickly so that we don't have accidents or crashes because of that wind shear. We also have what's called a mountain and a valley breeze. These are breezes. I want you to think about a nice, hot, sunny day. And we know that there is more air down here than there is up here. And a higher pressure then would be associated where there's more air. Well, gravity works. That's why the air is down here in the first place, right? So the air just can't move right back uphill on its own. But on a nice, hot, sunny day, this air gets hot and the air wants to rise and it wants to expand. And what will happen is the air pushes itself up the mountain as it gets hot. If you were standing on the mountain, well, you feel the movement of the air and it seems like it's going uphill. It's coming from the valley. This is what's called a valley breeze. We usually describe wind as where it is coming from. And in this case, it's coming from the valley because that's where the air is getting hotter and expanding uphill. So this is the formation of a valley breeze. It happens when the air in the valley gets hot, wants to expand, and pushes up the hill. Happens more often in the heat of the day once that air gets hot enough, like a sea breeze. However, when it gets cold, well, now that the air can't move back uphill, and the air that went uphill now gets a little bit cooler up here. Now it's cold everywhere, and all of that air that got up there now can't stay up there anymore, so it slides back down into the valley because it's getting colder and it's sinking. This is what's known as a mountain breeze. Because if you were here, or even if you're in the valley, you feel the air moving down the mountain. And we describe that wind as where the air is coming from, what's coming from the mountains downhill into the valley. So this is the formation of a mountain breeze. And they are more significant and tend to occur at night when the air is colder and sinking back down into the valleys. Check for understanding again. You must sketch the diagrams that are associated with these different types of small scale winds. Now, a couple last minute kind of in wrapping up kind of things about the weather. First of all, sorry about the wind. A weather vane. You might be familiar with these. You've seen these either in cartoons. You kind of know what they are. They're on tops of buildings, generally barns. They're very popular in farming areas because if you were a farmer and you were outside and way away from the house, you'd kind of want to know if the weather was going to change. And here's what a weather vane does. It shows you which direction the wind is blowing, which way is it coming from, which is generally what we are concerned about with the wind. We want to know, is it coming from the west, the north, the south, or the east? Because imagine that the wind is coming from the north. Well, we know the north is generally colder. Well, if the wind is coming from the north, I know it's getting ready to be colder. So historically, people who were outside, they would watch the weather vane to kind of help as a predictor of the weather. Because if the wind is coming from the north, think about in Kansas. Oh, now it's that continental polar air mass must be coming in. I know what is then going to be changed. But in Georgia, if the wind is blowing from the south, oh, that's coming up from the Gulf of Mexico. That's going to be warm, wet air, and it's going to give me a different set of weather conditions. So a weather vane, they're more decorative now, but you can understand why they were so important historically before we had smartphones and radios and even good weather reports in the newspapers. Now look at these terms here. Do you recognize some of these wind-related terms? Do you know what it means to be calm or to have a breeze? You might or might not have heard this term, gale. You understand the concept of a storm or a hurricane. Can you perceive what the wind is like if I said, oh, it's calm outside, or there's a breeze out there? And not just a breeze, but the difference between a light breeze and a strong breeze. You can perceive what the wind would look like. Now, historically, ships on the sea were very interested in the speed and or the strength of the winds because they had to set their sails based on what the wind was going to be. They also had to predict the waves because remember, the waves are driven by the wind. So if you had calm, you then had calm seas. If you had calm wind or calm air, you had calm seas. If you had a light breeze, well, then you've got a little bit more wave action out there. If you have a gale, a lot more wind blowing, well, then you're going to have a corresponding roughness of the seas. And these were all words that were primarily originally used by sailors to describe what the wind was without having to directly measure it. Because you think about it in the 1800s, for say, there was no way to have an anemometer for everybody. You couldn't use it that easily. You could have a barometer on a ship to tell you the pressure and the changing of the wind speed. So there was a scale that was devised using these words to help people predict the wind speed based on what they saw. And that's called the Beaufort scale. The Beaufort scale is a 1 to 12 scale, and it basically allows you to say what the wind speed is without actually having to measure it. For example, if we say the wind is calm, well, how do you know the wind is calm? Yeah, sure, you can't feel the wind blowing, but if you look at a smokestack, for a smokestack, you'll see the smoke rising straight up without being blown from side to side. Imagine you're a sailor on a ship and you want to know what are the seas going to be like when I leave the harbor. I look at the smokestacks and the smoke is rising directly up. Well, if the wind is calm, I'm not going to have a lot of high waves out there. When you start to get to a breeze, that's when you can actually start to feel the wind. You can perceive it. A gentle breeze starts to make tree limbs sway just a little bit, whereas a moderate breeze starts to pick up materials, papers and trash and other leaves, and start blowing them around. A fresh breeze will make a whole tree sway back and forth. A strong breeze will start to really shake the branches of a tree and even break off some small limbs. So these were all words that were used to describe the wind so that you didn't actually have to measure that. Now, in 2025, we don't need to go outside and try to guess what the wind speed is based on what we see. However, these words are still used to this day. But this is where they come from. They came from the Beaufort scale, which was developed for sailors primarily in the early 1800s. So your final check for understanding are these two terms here, and the words associated with the Beaufort scale.